All right, in homework 7.3, we're dealing with how interest works. And so in each of three sets, there's an annual rate compounded at the end of each year. There's an annual rate that's compounded monthly, and then there's an annual rate that's compounded continuously. I'm going to do kind of a checkerboard sequence here where I won't do all of them. This first one, it says invest $1,000 at a 6% annual rate, and we want to find out how much money you will have after X years. The amount of money you'll have will be the $1,000 you started with times, since it's growing 6%, we need to add in the 1 because 1,000 times 1 gets you back to the $1,000 you already had, plus we add in 0.06. We could also write 1,000 times 1 plus 0.06, but 1 plus 0.06 is 1.06, and that's a lot easier. So we'll multiply by 1.06 every year, and we will multiply by 1.06 x times in x years. So this is the formula that tells you how much money you have after x years. To find out how much money you have after 10 years, you would simply do 1,000 times 1.06 to the 10th power, which you can type into a calculator. In this next one, you borrow $12,000 on a credit card that charges 15% annual interest, but it's going to be compounded semi-annually. Semi-annually means 2 times per year. And we want to write an equation that will find us how much money we have in X years, how much we owe in X years, and find out how much we would owe after 7 years. So this time, the amount we're going to owe is the $12,000 we started owing. Since it's going to be increasing 15% per year, we still need to multiply by 1 because we'll still owe the $12,000 we owed before. But this time they won't charge you 15% interest. What they'll do is, because they're charging it to you twice per year, they'll take that 15%, which is 0.15, and divide it by 2. And they're not just going to give it to you, you're not just going to be multiplying by this x times, you're doing this twice per year. So after like 8 years, they would have charged you this interest 16 times. So the way we figure that out is it's 2 times x. However many years it's been, it's 2 times that. That's how many times you multiply by this to get the correct interest. So after 7 years, it would be 1 plus 0.15 over 2 to the 14th power, and you would type this into a calculator to get a number. It should be more than 12,000, but not like 20 billion or something like that. That seems crazy. You want to think, does your answer make sense? And I will do this one in a calculator just so we can see what I mean by reasonability of answers. 12,000 times 1 plus 0.15 over 2 to the 14th power is $33,000. So I hope you can imagine that if you, this is actually a really good deal on a credit card. Most credit cards charge way more than this. But if you take $12,000 out, 7 years later, you'll owe $33,000 if you didn't pay it back. The last one says we're going to invest $1 million, earning 8% interest compounded continuously. Compounding continuously means you're not just doing it every year or every month or even every second. You're doing it pretty much all the time. And this one has a different equation for it. This is the one that involves E. When you see continuously, it's going to involve E. And so it's A equals PE to the RT. That's the general formula. And so it's A equals 1 million times E to the 0.08t. Notice that this is not 1.08. The reason is you don't need the 1 there because e to the 0th power is already 1, and 1 million times 1 gets you back to 1 million. If you did e to the 1.08 power, you'd already be at a huge number at the end of the year. So to find out how much you have made, ooh, this is different. How much you made after 10 years. Well, the amount you have after 10 years is 1 million times e to the 0.08 times 10, which will be 0.8. But that's not how much you have made. That's how much you have. The amount you made would be how much you have at the end of that 10 years minus the amount you started with. So the amount you made is not the same as how much you have. The amount you made is how much your money grew by. So that's $2 million, a little over $2 million, minus $1 million is $1,225,540.93. We'll round this 0.28 to the second decimal place because when we're dealing with money, we usually round to the nearest penny. Another thing you should notice on this homework is that when there's an annual rate, that'll be less than if you compounded it in some number of periods. So this answer, whatever you got here, should be a little bit less than whatever you got here, which should be a little bit less than what you would get if you compounded it continuously. So that's a good way to check your answers is, did they go up by just a little bit? Because it shouldn't go up by very much, but it should be going up in each one of these sections. On the back, you are doing some properties of exponents, and you should remember from Algebra 1 that if you have two things multiplying with the same base, you add the exponents. The reason for that is x squared means x times x. X to the fifth means x times x times x times x times x. And if they're multiplying together 2 times, and then that multiplies 5 times 5 more x's, that's a total of 7 x's multiplying together. And that same property holds for when it's numbers. This is 15 times 15 times 15 times a bunch more 15s. And so the total number of 15s that are multiplying is 15 to the x plus 5 power. This bottom one's a little bit trickier. These are not the same base, and there are no rules for combining things. You can't multiply 25 times 5 because that would be violating PEMDAS. You need to do exponents first before you multiply. So you can't multiply these, and they don't have the same base, so as it's written, you can't do anything with it. But what you can do is you can rewrite 25 as a power of 5. 25 is 5 squared, and so we can rewrite it as 5 squared times 5 to the x plus 2, which is 5 to the x plus 4. I'll do one more explanatory one here. Here we've got 1/2 times 2 to the 7x. Again, we can't multiply these because they don't have the same base, but we can rewrite 1/2 as a power of 2. 1/2 is 2 to the negative 1 power. 2 to the negative 1 power times 2 to the 7x power. We can combine these, we just add negative 1 plus 7x. It's 2 to the 7x minus 1 power. Hopefully that helps on your homework.